So we will learn how to integrate today, okay? We're going to integrate simple functions, we're going to integrate fractional functions, and we're going to be able to calculate the constant of integration. And it's really exciting. I love integration, and this is a nice little introduction into it. So what we're going to essentially do when we integrate is we're going to find out what y is given the gradient function. So if we have the gradient function, we're going to integrate to find what y was. We will also then determine the equation of the curve. So as you can see here, a typical exam question is given the gradient function is this, find the curve that goes through the point 2, 3, determine y. So we've got the gradient function, we now want to find y equals. So, very importantly, so when we differentiate, okay, we multiply by the power, reduce the power by 1. So when we integrate, we are going to increase the power by 1, and we're going to divide by the new power. So, for example, it's very, very simple. Find y when dy by dx equals 3x squared. Now, it's very important that even though we're going to know the answer, we have to write the correct notation. So that means y equals the integral, and this is the sign for integration, y equals the integral of 3x squared with respect to x. Okay, so that would be our first step, is to write that. Now when we integrate, we increase this power by 1. 2 plus 1 is 3. Then we're going to divide this function by the new power. So I'm just going to show you what this looks like. Equals 3x, increase the power by 1, 3, divide by the new power. Okay? Now, some of us straight away, will be able to, whilst we're getting used to this, I want you to do it like this and then simplify. Okay? But straight away, we should know increase the power by 1 is 3, divide by the new power, 3 over 3 is 1. The integration of 3x squared is just x cubed. Okay, very important though, is our constant. We would then have to write plus c. So my final answer is y equals x cubed plus c. Now, I'm going to give you 60 seconds to tell me, why have I written plus c? C is a constant, by the way. Okay, a constant just means any number. Why have I written plus c? What is the point of that? 60 seconds, discuss with somebody next to you. Exactly correct. If we think about, just for a second, if we think about the equation, y equals 4x squared plus 7x plus 4. If I was to differentiate this equation, dy by dx, okay, bring the power down, reduce the power by 1. So 8x plus 7, and then the 4 would disappear, essentially. Okay, and we know why the 4 disappears, because this is an x to the 0, which is 1, and we reduce the power by 1, here it goes. So, we get 8x plus 7. So actually, what we're given is the gradient function. When we integrate this, we need to think, well, there could have been a constant. There might not have been, but there could have been. So it's really important when we integrate, we write plus c. So, here are a few examples that I'm going to do. Okay, we need to make sure we write this correctly. We're going to integrate 4x cubed with respect to x. Increase the power by 1, 4, divide by the new power, 4 over 4. So this is going to give me x to the power of 4 plus c. The next one, we're going to integrate x to the power of 5 with respect to x. Increase the power by 1, 6, divide by the new power is over 6 plus c. For this one, we're going to integrate x 3x to the power of a half with respect to x. Increase the power by 1. 3 over 2. Divide by the new power. 3 divided by 3 over 2 is in fact 2 plus c. Okay? Now, if your mental fractions aren't that good yet, okay, remember, if you've got 2 and we divide that by 3 over 2, that's the same as saying 2 times 2 over 3. I've done that wrong then, haven't I? Oh, it's 3, yeah. Here, so 3 divided by 3 over 2 is 3 times 2 over 3. They're going to cancel, which gives us 2. Okay? Again, this is something that I can do in my head. It would be really beneficial if you could get to that stage as well. Okay? Right then. Sometimes we have these fractional examples. Step 1. We always write it, just like when we differentiate, we always write it so x is the base and we could have a negative or a positive power. So in this case, 4 over root x can be written as 4x to the negative a half. So we're going to integrate 4x to the negative a half with respect to x, which equals, increase the power by 1. Negative a half plus 1 is a half. Divide by the new power. So x to the half means 4 divided by a half, which is 8 plus c. For the second one, we're going to integrate 5x to the minus 2 with respect to x. So increase the power by 1, minus 1. 5 divided by minus 1, minus 5 plus c. Okay, the next one, we're going to integrate 4x to the power of 2 over 3 with respect to x. Increase the power by 1. 5 over 3. Divide by the new power. 4 divided by 5 over 3 is the same as 4 multiplied by 3 over 5, which is 12 over 5 plus c. Okay, the next one, we're going to increase 10x to the power of minus 2 over 7 with respect to x. So increase the power by 1. 5 over 7. 10 divided by 5 over 7 is 10 multiplied by 7 over 5, which is 70 over 5, which is in fact 14 plus c. Okay, just to say, as we already know, this is saying, this is the differential function, the gradient function. This has already been differentiated. Now find f of x. Okay, so we need to integrate 2x plus 7 with respect to x. Increase the power by 1, x squared, 2x over 2, 0. Increase the power by 1. 7x, because remember this 7 on its own is times x to the power of 0, so increase that by 1, divide by the new power, which is 1, plus c. Question 2. We're integrating x squared minus 1 with respect to x. Increase the power by 1, cubed, divide by the new power, 3. Minus 1, increase the power by 1 is minus x, plus c. For the second question, we need to rearrange this. This becomes 2x to the negative 7. So we're going to integrate 2x to the negative 7 with respect to x. Increase the power by 1 is negative 6. Divide by the new power. 2 divided by negative 6 is negative a third, plus c. Cubed root of x is the same as writing x to the power of 1 over 3. So we're going to integrate x to the power of 1 over 3 with respect to x. Increase the power by 1, 4 over 3, divide by the new power. 1 divided by 4 over 3 is the same as multiplying by 3 over 4, plus c. 33x to the power of 5 over 6. We're going to integrate with respect to x. Increase the power by 1, 11 over 6. divide by the new power is multiplied by 6 over 11, but 33 over 11 is 3, so 6 times 3 is 18, plus C. Okay, if you are feeling super duper confident, guess what you're doing? The challenge. Okay, this is really confident. If you're feeling 5, and then if you're unhappy, can you do 4? Now, just a hint, step 1, make sure that your dy by dx, okay, your gradient function, is in the form where each term is base x, okay? So you can see all of these in question 3, all of them are in base x. So now you need to rearrange these to make sure they're in base x. 5 is actually in base x, so that's really easy. I really want everyone to be doing the challenge, but let's see. So step 1, I need to make sure I write this in a form so that A, I can expand it out, and B, each term has a base x. So 3 over x to the 5, remember, I'm going to split this up. This is 3 over x to the power of 5 plus x over x to the power of 5. 3 over x to the power of 5 is 3 over x to the power of negative 5. X over x to the power of 5 is 1 over x to the 4, which is plus x to the negative 4. So that's our first stage. We're now going to expand these brackets. 2x to the power of half times 3x to the power of a minus a half is 6x. Remember, when we multiply powers, we add them. A half minus 5 is minus 9 over 2. Okay? Then minus x squared multiplied by positive x to the power of minus 4 is negative x to the minus 2, because we add the powers. Negative x squared multiplied by 3x to the negative 5 is negative 3x to the negative 3. And then lastly, we're going to get 2x to the half times x to the negative 4. A half plus negative 4 is negative 7 over 2. So then, is that right? Yes. Okay, so now what we're going to do is to find y, we need to integrate this with respect to x. So, step 1, increase the power by 1, minus 7 over 2. Divide by the new power is negative 12 over 7. Increase the power by 1, negative 1. Divide by the new power, negative 1 divided by negative 1 is plus 1. But I'm just going to write plus. Increase the power by 1, negative 2. Divide by the new power, minus 3 divided by minus 2 is plus 3 over 2. Increase the power by 1, negative 5 over 2. Divide by the new power is negative 4 over 5 plus C. Here. So very quickly then, increase the power by 1, minus a half, divide by the new power, minus 2, plus 2x plus c. This time you can see our variable is t, and it says our variable is t because it says with respect to t. So we're going to increase the power by 1, t cubed, 6 divided by 3 is 2, minus x plus c. Now in this question it clearly says that p and q are constants to be found, and this is with respect to x. So we treat p and q like we would if they were a number, yeah? So for example, increase the power by 1, divide by the new power. P divided by 4 is just p over 4. Q is just a number, so when we increase the power on Q, we need to make sure that we're writing x and plus our constant from integration, C. Okay, so y equals 2x to the power of 5 plus 6 over the square root of x. Step 1, we rewrite our equation so that everything is to the base x. This becomes plus 6x to the negative a half. Step 2, we're going to integrate y with respect to x. Step 3, we integrate, increase the power by 1, 6, divide by the new power. 2 divided by 6 is a third. Plus or minus, increase the power by 1, a half. 6 divided by a half, 12. Plus c. Nice and easy, 3 marks. So as the answer, you should write the integral of y with respect to x equals. Okay, just stop what you're doing, everyone, and I just want you to rewrite this in the base x for me. Okay, so what are we going to be integrating? Just do that for me. For the base x, for example, on question 13, when we have y equals 3x to the power of 5 minus 4 over root x, to write this in the base x, I just make sure that minus 4x to the minus a half. So everything is now written to the base x. Okay then, so p over 2x squared, this is p over 2x to the minus 2. Okay, plus pq. So when we integrate, increase the power by 1, minus 1, divide by the new power, minus p over 2, plus pqx, plus c. Now, what we're going to do is we're going to do this by, we know that this equals 2 over x plus 10x plus c. So what we're going to do is we're going to equate coefficients, okay? So I'm going to rewrite the left-hand side. Minus p over 2 times 1 over x plus pq times x plus c equals 2 times 1 over x plus 10 times x plus c. Now, I wouldn't normally write it in this much detail in the exam. Okay, this is just an example. So 2 has to equal, okay, minus p over 2, because they're both multiplied by 1 over x. 10 is going to equal pq, and then everything else is the same. So, minus p over q equals, over 2 equals 2. Minus p equals 4. P equals negative 4. So then I've got pq equals 10. Negative 4 times q equals 10. Q equals 10 over negative 4. So q equals negative 5 over 2. And there's your answer. Nice and simple. So we've got q and p. So, to find the constant of integration. So, remember when we integrate, we have that constant. Now, that constant, as we know, if we think about the function, this constant affects the y coordinate. This determines where this position of the graph is, so whether we move it up or down, okay? Because, you know, our plus c on the end, if you think, when we integrate f dash of x with respect to x, we get f of x plus c, okay? And you think, inside or outside the bracket? Outside. Who does it affect? Y. Okay, so even though we have what, you know, if we have x cubed plus c, if c is minus 1, it'd be down here. If c is plus 4, it'd be up here, okay? It affects it. But if it tells us that the function itself passes through a specific point, we are able to find that constant of integration by using substitution. Okay, it's really, really simple. Here we go. Step 1. we know that f dash of x equals 3x squared. I always write it again to make sure it's in the base x, yeah? So that means y equals the integral of 3x squared with respect to x. If we integrate 3x squared, increase the power by 1, x cubed, 3 divided by 3, 1, plus c. This is now the equation of our function. It tells us it passes through the point 1, 3. Whenever we have a coordinate, we know our x value is 1, our y value is 3. So what I'm literally going to do, I'm going to substitute that in. So 3 equals 1 cubed plus c. 3 equals 1 plus c. c equals 2. Therefore, the equation f of x equals x cubed plus 2. Okay, step 1, it says find f of x, simplifying each term. So we know to find f of x, first of all, they are all of the base x. So straight away, I know that y is going to equal the integral of 3 over 8x squared minus 10x to the minus a half plus 1 with respect to x. So that means y equals. So then we're going to get increase the power by 1, 3 divided by the new power, 1 over 8, minus increase the power by 1 is positive a half, minus 10 divided by a half is 20, plus x plus c. Now, it wants the equation and it's given us a point that it passes through, 425. So we have to substitute in to find our constant of integration. So 25 equals 1 over 8 lots of 4 cubed minus 20 lots of 4 to the power of a half plus 4 plus c. Now, I would just put this whole thing into your calculator. So 25 equals 4 cubed is 64 divided by 8 is 8, minus 40 plus 4 plus c. So I'm going to get 25 equals minus 28 plus c. So that means c equals 25 plus 28, which equals 53. So for the final answer for part A, we're going to have y equals 1 over 8x cubed minus 20x to the power of a half plus x plus 53. It now says find an equation of the normal to the curve at the point 425. So for part B, if we're finding the equation to the normal of the curve, we've got to go back to differentiation. So we know that our gradient function is in fact 3 over 8x squared minus 10x to the minus a half plus 1. It wants it at the point 425, so my gradient when x equals 4. So remember, this gives us the gradient of the tangent when I substitute in this. I'm going to get 3 over 8 lots of 4 squared minus 10 lots of 4 to the minus a half plus 1. So the gradient of my tangent is going to be 16 to 6 minus 5 plus 1. So my gradient of my tangent is going to be 2. My gradient of my tangent is 2. The gradient of my normal is the negative reciprocal, which is negative a half. I have my point 45. So y equals negative a half x plus c. 25 equals negative a half lots of 4 plus c. 25 equals negative 2 plus c. c equals 27. So therefore, the equation of the normal is y equals negative a half x plus 27. But if we look at the question, it wants it in the form ax plus by plus c equals 0. So we just need to do some simple rearranging and multiplying. Multiply everything by 2 first. 2y equals negative x plus 54. And then I'm going to move everything to the left-hand side. 2y plus x minus 54 equals 0. Again, though, let's put x first. So x plus 2y minus 54 equals 0, because in the equation I want ax first. So now, exercise 9c. We've got the rest of the lesson. I suggest doing question 2 and 3 if happy. Questions 6 and 7, even if you're even more happy. Okay, and then question 8 in the challenge if you are ecstatic.